Hi and welcome back to class of Design of Machine Elements. I am Hitesh Raiyani, Assistant Professor at LJ Institute of Engineering and Technology. This is lecture 34, Introduction Springs. The learning outcomes of these lectures is to learn the introductions regarding springs like definitions of springs, applications of spring, types of spring, and whatever the terminologies used in spring. So in these lectures we learn all these basics regarding the spring. So let's start our lecture, that is the introductions. So what is spring? As we know, we seen spring in many applications. So spring is what? So spring is nothing but the elastic body whose function is to distort when the loaded and to recover its original shape when the load is removed. So whenever the load is applied on the spring, it's distort, and when we remove the load, it recover its original shape. That is nothing but this spring. So application of spring what? So first applications of spring is to control the energy due to either the shock or vibration. We can see in many applications spring is used to absorb the vibrations or shocks. So one of the applications of spring is to absorb either shock or vibrations. Second application is to apply the force, as in case of brakes, clutch, etc. So in this case, the spring is used to apply the force. And third is the store the energy, as we seen in the watches and toys, etc., where the spring is used to store the energy. So these are the applications of spring. There are many applications. We consider only 3 applications. So next is types of springs. So which type of spring is used in different applications we learn in this chapter. So first spring types is the helical springs. The helical springs are made up of wire coil in the form of helix and is primarily intended for the compressive and tensile loads. So its primary intent is to for the compressive and or tensile load. The cross section of the wire from which the helical spring is made may be either circular, rectangular or square. So whatever the cross section of spring, you can choose according to the applications. So there are no any restrictions. There may be cross sections of spring wire is circular or square or rectangle. So shows here figures a compression helical spring. You can see that here the figure A shows the compression helical spring. As a helical spring primary intent for the compressive or tensile load. So for the compressive load, the compression helical springs are used, and for the tensile load, the tensile helical springs are used. You can see the both the springs in figure. Here the compression helical springs and the torsion tensile helical spring is shown. Next type of spring is spiral or torsion spring. So there are torsion spring. This spring may be helical or spiral type. As shown in figure here, the torsion spring may be either helical torsion spring or spiral torsion spring. So you can see in figure here there are both helical and spiral torsion spring. So the helical type may be used only in applications where the load tends to wind up the spring and are used in various electrical mechanisms. So first case is our torsional spring is a helical torsion spring. So helical type are used in mostly the electrical mechanisms, and it is used only in the applications where the load tends to wind up the springs. And the spiral type is also used where the load tends to increase the number of coils, and when the made of flat strips are used in boats and clocks. So we can also see in clocks and toys or watches there are spirals torsion spring is used. So this is the second type of spring. Now third is the laminate or leaf springs. So laminate springs is here you can see there are number of strips is used which are clamped by clip and bolt. You can see here figure is the leaf spring. The laminate or leaf spring consists of number of flat plates. You can also see in figures there are number of flat plate is used, and which is clamped together by means of bolt and clamp. So this flat plate is known as the leaves of varying leaves, and the length of this plate is varying held together by means of clamp and bolt as shown in figure. This type of spring is mostly used in the automobiles. The major stress produced in the leaf springs are tensile and compressive stress. So most probably the spring in a leaf spring, the major stress is produced is either tensile or compressive or both. So you can see here the laminated leaf spring. In there are one master leaf spring, one master plate is shown, and then there are extra full length plates, and then graduated length leaves is clamped together by the means of bolt. So next is the terminologies or terms used in the compression spring. So first is the solid length. So solid length is what? As you can see in figure here, there are when the spring is compressed by the externally applied load, and when the adjusted coil is come to the contact, and whatever the length of this compressed spring is nothing but the solid length. So what is solid length? So when the compression spring is compressed until the coil comes into contact with each other, then the spring is said to be solid, and whatever the length of this spring is known as the solid length. So the solid length of this spring is the product of total number of coil and the diameter of pipe. So you can see visualization from the figure that if we have to calculate the length solid length, then it is nothing but the number of coils and multiply by the diameter of wire. So mathematically solid length of spring is LS. LS means solid length, and it is nothing but the N dash into small t. So here N dash is the total number of turns or coils. So here N dash is the total number of coils, and small t is the diameter of wire. Next terminology in compression spring is free length. So here you can see the compression springs which shows the free length. So whatever the free length, you can see that the length is shown as a free length. So the free length of a compression spring as shown in figure is the length of spring in the free or unloaded condition. So here in figure you can see that there are compression spring and it is unloaded condition. So whatever the length of this spring as the spring is unloaded condition, it is nothing but the free length. So to calculate the free length of this particular spring, mathematically the free length of spring is calculated as LF. LF is the free length and it is equal to solid length plus maximum compression plus the clearance between adjacent coil. So here LF is equal to, here solid length we know that it is n dash into small d, and the maximum compressions means delta max, and the clearance between the adjacent coil is if there are n dash number of coils and there are 1 mm gap between adjacent, then it is n dash minus 1 into 1. So if we adding all this length, we get the free length. Next terminology is the spring index. So spring index is defined as the ratio of mean diameter of coil to the diameter of wire. So mathematically the spring index C, it is denoted by capital C is equal to capital D by small d. Here capital D is the mean diameter of the coil and small d is the wire diameters. So C, capital C, that is spring index, is nothing but the ratio of capital D, that is mean diameter of coil to the wire diameter. Next terminology is spring rate. So spring rate, or you can say the stiffness of springs or spring constant, is defined as the load required per unit deflection of the spring. So whatever you can take the spring and for the unit extensions or unit deflections of that spring, whatever the load is required, that is nothing but this spring rate or spring constant. So mathematically spring rate K or stiffness of spring K is equal to W by delta. Here W is what? W is the load required to deflect unit length. So here W is the load and delta is the deflections of the spring. So K is W divided by delta. Now next is the pitch. As you can see here in figure, here compression helical spring is shown, and you can see in figure here the P, capital P, denotes the pitch of this particular spring. So pitch of coil is defined as the axial distance between adjacent coil and adjacent coil in uncompressed state. So here you can see in figure there are spring which is uncompressed state, and whatever the distance, axial distance between two adjacent coil, it is nothing but the pitch of that particular spring. So mathematically the pitch of coil is P is equal to free length divided by n dash minus 1. Here n dash is the total number of turns or total number of coils. You can also write P is equal to LF minus LS divided by n dash plus small d. Here LF is equal to free length of the springs, LS is equal to solid length or solid length of the spring, and n dash is the total number of turn or total number of coils, and small d is the diameter of wire. So in these lectures we learn the basics regarding the introductions of spring, like applications of springs, terminology using springs, and types of spring. In next lectures we learn the design of spring. Thank you.